This is our fourth lesson on radicals, and it's on multiplying and dividing radical expressions. We'll start out with some algebra that we already know, get warmed up. So remember that everything in the first set of brackets needs to get multiplied by everything in the second. So 3x times 3x is 9x squared plus 3x. Multiply that -1 through. 3x minus 3x is 0, so we get 9x squared minus 1. Okay, this guy we can rewrite as 4a minus 5b times 4a minus 5b, and do the same thing. So we get 16a squared minus 20ab minus 20ab plus 25 b squared. Collect like terms. All right, and now we'll do the exact same thing, but instead of x and y, we're going to have root 3 and root 2. So I get 2 root 9 minus 2 root 6 plus 3 root 6 minus 3 root 4. So notice the numbers multiply by each other and the roots multiply by each other. So 2 root 9 is the same as 2 times 3, or 6, minus 2 root 6 plus 3 root 6 is plus 1 root 6. And root 4 is just 2, so minus 12. Collect like terms, we get root 6 minus 6. Oops, no we don't, because 3 times 2 is 6. So we end up with just, oops, where's my eraser? Just root 6. Okay, and same thing again. Multiply those through, so I get 4 root 9 plus 10 root 3 minus 10 root 3 minus 25. 4 times 3 is 12, and it actually is 12 this time. 10 root 3 minus 10 root 3 is 0, so minus 25. So that's going to equal negative 13. Okay, and having the letters in under the root instead of the numbers just means we have to do one more step, which is to say in this case that a is greater than or equal to 0. So we're not trying to square root a negative. So I get 12 root a squared plus 15 root a minus 8 root a minus 10. So in this case, we don't need to put the absolute value on because we know a is positive already. So that's just 12a plus 7 root a minus 10. If you were to put the absolute value on the a in this case, in the first a, it wouldn't be wrong. Alright, so let's have a look at the modified part b I've changed here. So first thing we're going to have to say that x and y are both greater than or equal to 0, so that we're not taking square roots and negatives. And then we can rewrite this as 3 root x plus root y squared. Oops. That's what we already had. We need to write it as it times itself. And now just rainbow that in. And we get 9 root x squared plus 3 root xy plus 3 root xy plus root y squared. Notice we don't need the absolute value here because x and y are always positive. So we'll have 9x plus 6 root xy plus y. And we're done. Alright, rationalizing the denominator. So Anything with a radical on the bottom is not considered simplified. This is back from the days of when they used tables for this stuff in long division. Unfortunately for you, it's still the standard. So we need to get that square root 2 to change to a 2. We can do that by multiplying top and bottom by root 2. So we get root 2 over the square root of 4, which is just 2. Okay, so let's have a look at example A here. I'm going to multiply top and bottom by the square root of 5. Remember, anytime we have big fractions like this, it's as if there's brackets over the top and the bottom. So I'm going to have to rainbow that root 5 in. So that's going to be 4 root 25 minus 2 root 5 all over root 25. Of course, root 25 is just 5, so we have 20 minus 2 root 5 all over 5. That is considered simplified. Okay, part B. Before I decide to multiply top and bottom by root 12, I'm going to turn root 12 into a mixed radical. So root 12 is the same as 2 root 3. And now I can just multiply top and bottom by root 3. That's going to save me some canceling later on. So I'll multiply that root 3 through. I get 9 root 6 minus 3 root 15 all over 2 times root 9 is 6. Okay, and now we've still got 3's on the top and bottom we can get rid of. So let's factor a 3 out of the top. And now we can go 3 over 6 is the same as 1 over 2. So we get 3 root 6 minus root 15 all over 2.